One of the biggest confusions in multivariable calculus is showing whether or not a limit exists. So I am going to answer that in this video. First of all, this is actually a very good question. And let's show you when a limit doesn't exist. That's actually very easy. A limit doesn't exist if the value is different, the values are different from two separate curves. So it's very easy. You just have to show that the values are different along two different curves, and then you can prove that the limit is not existing. So let me give you two examples of this. So lim x, y goes to 0, 0, 2x squared plus y squared over x squared plus y squared. Okay, and let's first try along the x-axis, which is when y is equal to 0. Then you'd have lim x goes to 0, 2x squared over x squared, which is equal to 2. Now let's try along the y-axis when x is equal to 0. So lim y goes to 0, y squared over y squared. That's just 1. And these two values are different, so limit does not exist. The second example is lim xy goes to 0, 0, xy over x squared plus y squared. Okay, and let's try x-axis and y-axis. Y equals 0, lim x goes to 0. Then you'd have x times 0 over x squared. This is clearly 0. Y-axis, x equals 0. Lim y goes to 0. Y times 0 over y squared is equal to 0. And these two curves have the same value, but that doesn't mean we've shown the limit exists, so we need to try another curve. Let's try x equals y. So lim x goes to 0, you'd have x squared over x squared plus x squared is equal to 1 over 2. This is not the same as 0, so the limit does not exist. Very easy to show a limit doesn't exist. Just show that it's different on two different curves, and that's it. I recommend starting at the x and y axis. That's the most obvious direction to start, and then working your way up. What if a limit actually exists? Like you've tried every single curve you could think of, and you still get the same value. Well, you can't. That doesn't prove that the limit actually equals that exact value. So you need a different approach. And there are three different solutions you can use to show that a limit exists. Factoring, squeeze theorem, and polar coordinates. So let's start off with factoring. I have three different examples here. Lim xy goes to 1, x squared minus y squared over x minus y. Well, this is just equal to, you can divide out the x minus y, x, y, sorry about that, 1, x plus y, and this is just equal to 2. The second example is lim x, y goes to 2, 1, x squared y minus 4y over x minus 2. And you can also factor it out like this. Let's go to the numerator. Factor out a y, x minus 2, x plus 2, because that's just equal to x squared minus 4, over x minus 2, which is equal to lim x, y goes to 2, 1, y times x plus 2, which is equal to 4. And the last example I have is lim x, y goes to 1, 1, x cubed minus y cubed over x minus y. The answer to this limit is 3. And how is it equal to 3? I'm going to leave the thinking to you. So try it out yourself and you'll see that it equals 3. The second way is the squeeze theorem, and I have some examples for this. Lim xy goes to 0, 0, 3xy squared over x squared plus y squared. And it doesn't look like we can factor this, so what we do is we use the squeeze theorem. First of all, let's consider the absolute value of this function. 3xy squared over x squared plus y squared. Okay, this is equal to 3 absolute value of x, y squared, over x squared plus y squared. And then we can say that this is strictly less than or equal to 3 absolute value of x, y squared over y squared. Because we remove the value of x squared, the denominator value becomes smaller, which naturally would increase the total value of this function. And the y squareds cancel out, and this is equal to 3 absolute value x. So we can say that 0 is less than or equal to 3xy squared over x squared plus y squared, which is less than or equal to 3 absolute value x. We can apply the limit on all three sides. Okay, so this equals 0, and this equals 0. So by the squeeze theorem, the limit This limit is equal to 0, the absolute value. So that would mean that the original form is also equal to 0, and that's our answer. If you want to use polar coordinates, it's super easy. All you have to do is say x equals r cos theta, and y is equal to r sine theta. X and y are both guaranteed to be 0 if r is equal to 0. So what we have here is lim r goes to 0. Probably, you can say plus, because r can never be negative, but this plus sign really doesn't matter. And then you just plug in x and y. 3 r cos theta times r squared sine squared theta over r squared. So on the numerator we have r cubed, and the denominator r squared. That just leaves you with r, so lim r goes to 0 plus, and you'd have 3r cos theta sine squared theta, which is just equal to 0. And we've once again proven that the limit is equal to 0. Okay, now let's try another limit. Lim xy goes to 0, 0, x cubed plus y cubed over x squared plus y squared. We can use the squeeze theorem or polar coordinates, either works. Let's use the squeeze theorem. X, consider the absolute value of the function which is equal to x cubed plus y cubed over x squared plus y squared. And you don't really know what to do here. You might not know until you remember the triangle inequality. Triangle inequality that states that absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. This is what we're going to use. So this is equal to x cubed over x squared plus y squared plus y cubed over x squared plus y squared. And we're similar concept to the previous limit. This is less than or equal to, so absolute value of x cubed over x squared, because removing y squared gives you a smaller denominator value. And similar concept here, y cubed over, remove the x squared, so you're just left with y squared. And this is equal to absolute value x plus absolute value y. So we can once again say that this, same idea as last time, x cubed plus y cubed over x squared plus y squared less than or equal to x plus y. I'm going to speed this part up because I already showed you guys this part last time. So that's pretty much it. In conclusion, first find or try to prove the limit doesn't exist. And I actually have a cheat code. Here's a rule of thumb. Try the x-axis y equals 0, the y-axis, x equals 0, y equals x squared, and x equals y squared. If they all give you the same valued limit, like 0, then you can suspect the limit exists, and then try the squeeze theorem. If all give same value, suspect the limit exists. You might suspect the limit exists at this point. So then, you can try the factoring, squeeze theorem, or polar coordinates, like I talked about earlier. I will give a bit of a caution on this one, because I once lost marks when I was a student for using the polar coordinates because my professor didn't go over this. So if your professor did not mention polar coordinates, then I don't recommend you use this, or else you'll risk losing marks on the exam. The squeeze theorem is your best bet. If that doesn't work, try factoring. Yeah. As I mentioned in my channel description, I am able to teach grade 10 math, grade 11 math, and grade 12 math, calculus 1, calculus 2, and calculus 3, linear algebra, and ordinary differential equations. I'm going to be uploading content about those subjects on this channel, and if you have any questions that you want me to cover, you can either let me know in the comments or email me at ingenerally@gmail.com with 3 L's. That's where I respond to questions related to math. So, yeah, that's about it. I love to stay, but I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.
I'll be the best escape of the in-between. I'll be the first step to a brand new scene.